Hello, everyone. I'm Susan Nash, AAPG. I'm thrilled to be here today, and we have a wonderful program. I'm excited to see that we have a great turnout today, and we'll continue to see people coming in to the meeting. We have a wonderful set of presenters today on our topic, which is geothermal resources and critical minerals. And this is for new developments and to focus on what's going on and the exciting developments. So we have our first three speakers. We have Joseph Batir of PetroLearn, and he's a geothermal lead. And and then we have Tom Smith at Brine International, a brand new company. He was at U.S. Strategic Minerals, and he's going to focus on the brine mining. And we have Saeed Salehi, Associate Professor at University of Oklahoma, head of the Geothermal Consortium. And we also have Ellie Mckinnis, special guest, who will be talking to us about a new geothermal database, and that also has a lithium guide, or guide to finding lithium, and it's global. So what I'd like to do right now is have a moment to introduce our special guest, who is Mike Bingle Davis, who is the president of Energy Minerals Division. So welcome, Mike.
Thank you. It's a great honor to be here. I'm actually in Myrtle Beach, South Carolina. I've been president for approximately 11 days now, so it's great to see something like this already started up and already going. So thanks, Susan, and thanks everybody for coming, as well, especially to those that are speaking today. It takes things like this in order for us to be able to function and move forward. So it's great to see it happening. Some of the things we're going to be doing with the Energy Minerals Division this year is trying to reach out and discuss things with more local individuals, some more of the counselors that are involved from different parts of the world, to kind of get a view of the supply chain, critical minerals, things like geothermal. Where does it work? Where it's not working, who's using it best, that type of thing. It's good to get a more hands-on view of it all and to actually have conversations about that. So I'm really looking forward to implementing some new things this year, and hopefully we can get as good of attendance as we have for this particular presentation for some of the things we have planned in the future. So thank you. I could keep talking, but I'll leave it short and let the speakers do their thing. So thank you, Susan.
Well, thank you. And I just want to emphasize the Energy Minerals Division is doing a lot of things and very exciting. I'd like to encourage you to check them out. If you're not a member of EMD, just check the box. And also like to encourage you to renew your membership and join if you haven't. And also to join us at our meeting at Image, August 29th through September 1st in Houston. So with that, I'd like to welcome Joseph Batir of PetroLearn. So welcome, Joseph.
Hi there. So my name's Joseph Batir, and we're just doing introductions now, right? So
no, you're good to go. I've already done
great.
all the introductions. They're brief.
All right, that sounds great. So yeah, let me jump in and give you my presentation a little bit on what we're doing here at PetroLearn. So for those of you who don't know PetroLearn, we are a consulting and technology company working on developing new ideas, new tools, new technology. We're focused on bringing geothermal to sedimentary basins and focus on repurposing wells, as well as developing new ideas and new tools. Today, I'll just go quickly through and talk about a recent project that we finished for the state of Wyoming. So the purpose of this project was for the Wyoming Energy Authority assessing the feasibility for geothermal opportunities characterized by geothermal utilization technology and its effectiveness in certain Wyoming regions. We looked at the geothermal resource characterization, utilization of new technologies, and then did some high-level financial modeling, regulatory environment, risk assessment, those kind of aspects. So going into the key takeaways. I'm going to try and keep this brief so that way we have plenty of time to discuss everything. Giving you those key takeaways right off the bat. Existing infrastructure provides significant value potential for repurposing. Previous energy development, that being oil and gas wells and oil and gas infrastructure, that supplies the necessary data source to drive understanding and project de-risking. And resource understanding plus new technologies will enable a decarbonized future. Now, why do I come up with those key takeaways? Well, that first step we did was that literature review, looking at the geothermal heat flow map for the state of Wyoming. This is work done by Ryan Dingwall and others through SMU back in 2011. Note that 2011, that was the most recent work done. What they showed is that in the sedimentary basins, most of these basin areas are low to intermediate temperatures. There are some major aquifers greater than 120 Fahrenheit, which we'll talk about later. And the heat flow in general is between 33 and 80 milliwatts per meter squared. For context, continental average is 50. So anything that's in these greens and blues, that's kind of continental average. There's a few areas that are hotter or a higher thermal regime than that. And then of course you have Yellowstone. Yellowstone's kind of off limits. Let's all accept that and go enjoy the hot springs and enjoy the nature as it is, and let's not try to develop it. So big points is that there's no real widespread hydrothermal resource in the state of Wyoming. There are 3 different development options then. There's EGS, or enhanced geothermal systems. There's repurposing of the existing wells, and there is new technology utilization. So let's walk through those one by one. To give you context in terms of geospatial context, I'll kind of talk in general about the state, but we really looked at each different major sedimentary basin and we broke it down, examining each one in the final report we submitted to the Wyoming Energy Authority. So different things that we looked at were the well data. We took the well data and we examined over 11,000 data points, many of these coming from the National Geothermal Data Survey, temperature and depth data in the SMU database, and then also the hot spring data from the USGS. We analyzed these for both regional thermal resource, that being for new geothermal development. We looked at well repurposing for power, so locations of wells that were greater than 200 Fahrenheit. And then we also looked at low temperature wells for heat, that being all the wells that are less than 200 degrees Fahrenheit. Going through those results one by one, that first one, the resource characterization for new projects, new drilling, we chose a depth to 125 degrees Celsius. It's about 250 Fahrenheit. The reason we chose that temperature to make this temperature depth map is because that's kind of the target that we've seen from multiple different projects right now. One of those being deep earth energy production in Canada. So if you look at the state of Wyoming, there are ranges anywhere from 4,600 feet up to 13,000 feet. That means you have to drill to that depth to hit these temperatures. 4,600 feet, that sounds like that could be viable. That could be an economic project. 13,000 feet to hit 125 Celsius, that may not be as economic, as profitable. So here, variability really does matter on where you could have a viable project. Note the Denver and Cheyenne Basin. This is the best area outside of Yellowstone for these new drilling targets. We did some basic financial modeling, kind of looking at the whole thing and looking at that variability. The depth, the financial viability really does depend on that drilling depth. We calculated estimated IRRs of anywhere from 6 to 13%. The details of those numbers and how we got to those, you can find in that final report. Moving on, so that was new drills, but there's a lot of wells already existing in Wyoming, and we want to think about reutilizing this existing infrastructure so that we could maybe reduce some of that cost. As we know, drilling cost is a major component of geothermal projects. So if we can repurpose wells, we can save some money on that new drilling. So that first step here, we're looking at all of the wells that are hitting a bottom hole temperature of less than 200 Fahrenheit. These are the wells that would be capable of being used for direct use applications. The main takeaway here is that there are many wells pretty much throughout the state that are high enough temperature for direct use applications. This is something that I think we don't talk about enough. We have all of these wells, and most wells drilled are going to be somewhere in that 100 Fahrenheit and above range. For really throughout the US, you're going to be able to use that energy at some point throughout the year. And that's something that we should think about. So here, when we look at using this heat directly, the IRR estimates are anywhere from 9 to 37%. So here, significantly more viable if we can find that power source, that being the heat, as well as the demand for that heat. From there, we jumped and looked at electricity potential. These are wells specifically that are greater than 200 Fahrenheit. And also we looked at wells that are depending on their well status, meaning are they producing wells? Are they P&A'd? Are they shut in? Or do we not know anything about them? Notice here that there are wells, again, kind of throughout the state, but there's a significantly lower number. And then if you were to take that one step further and look at just the producing wells, those producing wells being the ones that are most opportune for repurposing, there again is going to be fewer wells. So here in the southwestern portion of Wyoming, and also here, we can see a lot of producing wells and wells that are fairly high temperature for their bottom hole. The rough financial estimates that we calculated here for repurposing wells was anywhere from 11 to 18%. So still a good number, better than drilling new wells if everything works out the way it's anticipated, but not necessarily as good as direct use. Now that was all the existing infrastructure, the existing opportunities. One idea is how can we use future technologies to develop these resources and utilize both the existing resources in infrastructure and all of the other potential opportunities. One idea is the synthetic geothermal reservoir that we work on at PetroLearn. Here, looking at in Wyoming, there are these big, large, vast basins. These basins have significant aquifers that are existing. Those aquifers, if we can pump heat down into those aquifers, we can use those for thermal energy storage. So if we're looking at the state of Wyoming, these golden lines are transmission lines. These shaded areas are aquifers or aquifer geospatial footprints. And you have some of the towns, and the blue in the background is the wind potential maps coming from NREL. If you notice, areas like Casper, areas like Cheyenne, these are areas that have lots of transmission lines. They have very, very good world-class wind resources, and then also are very close to aquifers where you could do thermal energy storage. So this is one area that is a way to potentially look at reutilizing infrastructure, reutilizing the known information in the subsurface, and then combining it with new technology and new innovation on putting everything together. I think I'm running a little long, so I will go ahead and skip through this slide. So the conclusions from this work were that in Wyoming, there are localized areas of low to moderate temperatures, anywhere from 100 to 250 degrees Fahrenheit. There is no widespread high temperature geothermal reservoir, unfortunately. So conventional geothermal is going to be more difficult to produce. But there is significant existing infrastructure, that being existing oil and gas wells, and that being large transmission lines. This is something where we could start utilizing that in a new way. The best ways we see for geothermal utilization is either the resource type is best utilized with direct use technologies. There is potential to repurpose wells with an ORC, or organic Rankine cycle, if the water production is high enough, and if you're looking at one of those wells that is high temperature. And new well drilling is possible in some areas, but it is going to be dependent on that local thermal regime and that's going to determine whether or not that's economic. And finally, there is opportunity for new technology development, that being in SGR or thermal energy storage, because there is large swaths of land where there's co-location of aquifers, transmission lines, existing infrastructure, and that high wind resource. I'll just flash my email up here, and I think that I will stop sharing, and I think we're doing questions at the end. Is that right?
That's right. And thank you, Joseph. That was fantastic. Really appreciate it. And really think that there's a lot of potential. I really like some of the things that you brought up. So we'll definitely have time for questions. We'll save the questions for the very end, and our speakers have agreed to stay on later so that we can answer questions as long as you like after the top of the hour.
Yeah.
So thank you.
Yeah.
And I'd like to, yeah, thank you. So I'd like to welcome our next speaker, Thomas Smith, GeoBrines International. So I'll go ahead and share my screen. And if somebody can help get people through the waiting room, admit people in the waiting room while I'm driving the PowerPoint, that would be great. So Tom, do you want to go ahead?
You betcha. Thanks, Susan, for putting up with me this morning. I don't know what happened, but I've always been able to share the screen. It's just something up. So I'll go ahead and start it off. Go ahead and click it once. I think there's a couple clicks per slide. Okay, so GeoBrines International is a new company, and we're essentially just improving on a little more focus toward subsurface brines, and not so much for carbon capture, but also applications now with geothermal and thermally and chemically stable brine that you can extract from the subsurface, sometimes along with oil and gas production, has value. And I'm going to show you just a little bit of the application for EGS, so enhanced geothermal systems, especially in open loop, hot, dry rock type applications for EGS. So similar to what's going on down at the Forge, DOE-funded Forge site down in Milford, Utah at this time. So GeoBrines International is a hybrid exploration and production group, ex-oil and gas, and really we've been developing carbon capture technologies that promote sourcing of rare and critical minerals from subsurface brines and waste sites in the U.S. and other favored nations. Go ahead and click. And so some of the things we've been doing in the last couple of years is looking at funding from DOE. Actually, in the final review and award for a DOE project, it's going to be looking at energy relevant elements. It's the minor program, working with some folks at various universities throughout the US. We're going to go ahead and focus on Utah and brines in Utah, and potentially, I mean, the biggest thing we're looking at right now is lithium, obviously. That's front and center, but there's other minerals in there that are valuable. Go ahead and click again. And so these partners can help, fund some of this startup, get us through this early funding stage where we can move forward with this technology, get patents filed and different things moving along. Go ahead. And so we do have a solution for the carbon footprint, and that's Mine the Brine. That's a trademark of ours. And hopefully when we get funded, we're going to get some hats and coffee cups and some stickers that say Mine the Brine. Go ahead. So how can geoscientists transition? Go ahead and click. So the first thing, most of us look at, we have blinders on. Oil and gas engineers and geologists tend to think that only thing, if you drill something and you don't find oil and gas, it's a dry hole. And then if you do find brine, that is a cost, cost of operation. It's an OpEx. It's not good. Even if you complete the well, water always tends to increase, oil tends to decrease. So if we could get a revenue stream coming from the brine, I think that's a well accepted revenue add for any operator. And so we say, look at what's in the brine, sell, the products that we can derive from the brine into these large markets, sell lithium carbonate if there's lithium in the brine that you can extract. The other thing to look at is that, a lot of us say, well, how do we find a prospect? So look at the well data, look at all the borehole data, look at the water analysis. Don't just look at wells that were actually completed, but look at all wells and look at any DST water analysis. Look for high TDS. So we're looking for a lot of minerals in the water. Typically, I'm going to show you water analysis in a bit, but typically there's some good things, and that's really what we want to focus on. Also, look at the gas composition. Look for helium and hydrogen. You're going to have CO2 with that, but there's a way we can sequester that CO2 and actually make a valuable product using the calcium in the brine. Another concept is, go ahead and click, is to be a leader, be an explorer and look outside, outside the barrel, as we'd like to say, and, look at other technical disciplines, whether it be geochemistry, just straight up chemistry, water chemistry, all very cool stuff. Not just focused on, what you think that your job should be. Look outside the barrel. And finally, a lot of us, go ahead and click. It's good to, propose, to management that there's an ESG, and critical minerals extraction focus group, and because that is what all of us are striving for at this point. These large companies, especially with net zero goals. Go ahead. Next slide. Okay, so the Paradox Basin of Utah is kind of a focus we'll talk about, but it's been a kind of a go-to basin for many years, since the 50s, starting with the uranium. Then you've got potassium, potash, lithium is present in these brines that come up with the oil and gas wells. There's a lot of these salt brines, and there's now as helium has come to the forefront along with hydrogen. It's going to come with a lot of CO2. So we have to have a solution for that CO2, which we do. Go ahead. Next, early oil and gas exploration. We had deep tests for Lisbon-sized fields. This is mainly a lot of state and federal, a lot of running room out here, well understood. Go ahead and click down a few more. Thank you. Reservoir. So this reservoir brines here have high TDS and the point of saturation. And now really the targets for brine mining are typically calcium, magnesium, potassium, and now lithium come to the forefront. That solution mining for potash is successful. It uses similar exploration techniques, but you actually have to drill wells and inject, and solution mine out rock and dissolve it, where we're using nature has already put these minerals in the water, and it comes up with the oil, and sometimes artesian form comes up as you produce the oil and gas. And so we don't need surface evaporation ponds to concentrate that down. Nature's already done the work for us in the reservoir, in the subsurface. Go ahead. So Paradox is kind of where we focus with Geo Brines and my predecessor company. Like I say, there's some 2D out there, limited 3D, looking at well control, looking at these pressure gradients. You find that this is a very highly pressured, overpressured bunch of reservoirs here in the Cane Creek on down to the Mississippian. Go ahead. So we found a well that, looking through some our GeoBrine reservoir, was identified by a well that was a dry hole, was plugged in 1997, and encountered a highly pressured calcium chloride rich brine. Got some analysis and found out that this product is as valuable as oil on the market. There's only 12,000 barrels a day of this particular type of supersaturated brine on the market in the US today. And so it's a large market. We want to add to that with an additional well. Go ahead and click. And the other place in the US that this is semi-prevalent is in the Smackover, southern Arkansas, northern Louisiana. Folks have been taking out bromine, now lithium. There are good markets for that. Albemarle's the big company down there, been operating in that area for many years. Go ahead. And so the critical minerals list, if you take a look at the list that the USGS put out, you see things like manganese, magnesium, rubidium, yttrium, zinc. Those are things that tend to be in these Paradox Basin brines, along with the lithium, especially, is what the target is right now. Go ahead. And so, go ahead, click down. So when you're brine mining, you know, the basics are, you're looking at claims versus oil and gas leases. You take a placer claim, so that's point of source. There's typically no revenues or royalties on the revenue from the brine mine. Much lower severance tax, if any. And so you put together a mine plan, and you also, if you're drilling, going to have an AAPG process, but it goes through the Bureau, you know, the mining group versus the oil and gas group in Utah, at least. Go ahead. And so, yeah, the 1872 mining law is still in effect, and that's a good thing. Go ahead. Okay, so critical minerals, you know, how do we get into these databases? What's out there if you want to go after some of these projects and potential sites, mine sites? So you have all your public data. The claims are actually filed at the county courthouse. You got the US DOE, the Geological Survey, NETL, a lot of data out there, finding opportunities, reports, trade publications are all there. I want to introduce Taranexum.com. So that's a new global optimizing platform that actually links up people needing carbon solutions. And it shows it's helping subscribers across the globe achieve their net zero goals. So that's a new company startup, folks we've met here in the Denver area. Miningintelligence.com is the mining industry's real-time database, similar to Enervis for oil and gas. And then just presentations and panels like we're doing right today. Yeah. Go ahead. And if you're seeking capital, you know, pitch presentations at conferences and VC events, and that's been doing some of that the last couple of years. And so produced water is everywhere. So if you look at what Texas has done, the governor here in 2021 created the Texas Produced Water Consortium to study the economic impact of produced water on the state, and they produced 50 million barrels a day of the 100 million produced in North America alone, and that's just oil production associated brine water. So it's out there. Go ahead and click. And so looking at a water analysis, typically you're going to look for milligrams per liter. You were looking for big numbers. In this particular one, we see calcium's kind of the largest, sodium's fairly large, again, 56,000 milligrams per liter. But you also want to look for lithium. I mean, that's what everyone's going to focus on right now. You see 57 parts per million. So there is some lithium in that. Typically, it doesn't get much higher than 200 part per million anywhere. It's always, so you have to move a lot of volume to get a lot of lithium out. So you have to have concentration and volume in all of this brine mining. Those are the two kind of knobs you want to be looking at, because it is what it is. What comes out of the ground, you're not going to change it other than by concentrating it. So go ahead and flip to the next, will be the cation or the anions. The complementary side, you're going to have, usually most of these cations are present as chlorides or sulfides and sulfates. You kind of want to be toward the chloride side. Bromide in there is that's very valuable, similar to the Albemarle stuff. So that's typical water analysis that has some goodies in it for extraction. Go ahead. And, looking at just the final part of the water analysis, typically you're looking for here, the resistivity is going to be very, very low. You're going to see a specific gravity. The higher it is, the better. Water is 1, essentially. Anything as high as 1.4, 1.5 is loaded with a lot of TDS, a lot of valuable minerals, hopefully. So that's just another barometer, quick reference that you can, throw into a database. Go ahead. So global problems, what's our solution to CO2? Go ahead. We have technologies. Now there's been some incentives here that have increased the Section 45Q for carbon capture utilization in making products out of it, not just storing it underground and making, let's say, calcium carbonate, has increased from $35 a metric ton sequestered up to $60. That's just recent with the IRA passage of the Inflation Reduction Act bill. Go ahead. And then go ahead again. Yeah. And so where do we find this? Well, most oil and gas fields and mining sites, especially where you have CO2 available and the large volume of wastewater, that's really where you want to focus in on. You want to have this logistical synergy that allows you to make an economic project, and even with or without the Section 45Q. Again, thing we target right with our technology that we have is the PCC. So that's a very high grade calcite, very white. It's a specialty mineral. It's used in paper whitener and pharmaceutical. Anything that's white tends to be calcium carbonate. Go ahead. So anyway, in the geothermal, so this is kind of where we're really wanting to go with GeoBrines International is just filed a patent that's going to be very key to managing the reservoir, the EGS reservoir, and actually getting the heat out of the reservoir in spite of what we end up with as far as a fractured reservoir and flow paths and short circuits. How do we correct short circuits? Well, our patent is to mineralize that short circuit using calcium carbonate, i.e. calcite. So calcify that fracture in situ. And so at a high temperature in the reservoir. And so that is really, I think, as we go forward with geothermal and EGS, the drilling is going to get solved, but we really don't know how much heat output we get until we sit there and put in the water, the brine. And what we want to do is use a thermally and chemically stable brine for injection for processed fluid. If we do need to correct a flow path, we simply pump CO2 in a pH adjuster, and we calcify a thief zone or a short circuit fracture in situ. And so that's the patent in a nutshell. We're really excited about getting in with Forge down in southern Utah when they get ready to start pumping processed fluid in, just to see, if they don't get the heat output they expect from the modeling and whatnot, and we do see that there's flow paths that need corrected, we can address those. And that's basically the talk. I hope it didn't run too long. Give me a buzz. We don't have our website up yet, but it's coming. And most of you know how to reach out and find me on LinkedIn as well. I appreciate Susan.
Oh, thank you. Oh, that was wonderful. And it's exciting that you're right at the beginning of this new patent and new process. And it's a fantastic segue to Saeed Salehi, who's a professor at the University of Oklahoma and head of the Geothermal Consortium, where they're doing a lot of exciting things about converting old abandoned oil and gas wells into geothermal. So it's very exciting. So welcome.
Okay, hello everyone, and thank you, Susan, for the introduction and inviting for this wonderful meeting. One of the reasons I like to be last is first I hear such a great presentations from everybody else, and second thing is it's just a good intro to the talk I'm going to give today. And at the same time, I think we are at the crossroads of both energy crisis and supply chain problems, and I think it's the perfect time to discuss about the synergies that exist between the geothermal to critical elements mining, and also the produced water and oil and gas energy, and the relationships that we can have between all of these segments. So today I'm going to talk about a recent project, hydrocarbon wells upcycled to geothermal. It's not the name of the project, but we came up with this name 2 months ago when we were presenting in UTech UPitch with the help that Susan invited us. So as a new acronym, HOG, that we are coming to, to sort of demonstrate the conversion of some of this oil and gas wells to geothermal. So going through some of the major concepts here, the approach that we're going to take is very simple. We are trying to recycle or upcycle some of the existing oil and gas assets and try to produce energy from it, because we see a lot of these oil and gas wells have been drilled in low to medium temperatures. They have reasonable heats. There are some of them with potential for electricity, and it's been a big investment with a lot of these energy companies, drill through these wells, and they can also be a cost saving and also environmental footprint if we are able to upcycle these wells. So if I just go to next, this is not just related to one community to another. So you see a lot of these wells sitting in different states, different parts of the US, even globally. You can see a lot of these wells are spread around. And as an example, a lot of these wells are within the communities, within maybe feet or maybe few miles from the communities, from population centers, and they could serve the community. It's not just oil and gas that have been produced. Now there are depleted formations, but you can still use energy or exploit the energy from these wells. So if you drive by many of the states, maybe in Oklahoma or Texas, you won't be surprised to see a lot of these wells. Even in the middle of parks, close to hospitals, close to factories, you can see them in the backyards of the people. A lot of complaints we have that, okay, methane emissions, noise, or the other, pollutants from these wells. So there might be a solution that you don't need to plug and abandon all of these wells. You can, try to convert some of these wells for the geothermal applications. There are big fields. You can see, there are fields in Baker Fields, California, or many other places that hundreds of these wells are sitting. And we are not proposing to maybe use or convert all these wells, because some of them may be old or are leaky or have issues, but there is a good percentage that you can even, power small cities or medium-sized industrial factories or other type of end users or applications for the geothermal energy. You can also produce oil and gas, and at the same time also produce heat or electricity at the same time. So there are different business models that you can have to leverage these assets. So how big is the resource? So it's not just hundreds, it's not thousands, it's millions. So based on some economic analysis, this is $3 to $4 trillion assets that are spread around different places. If you look at, for instance, in the US, to some estimates, there are about 3 million wells in total in terms of, the abundance or, inactive. And we also have about 1 million active wells right now. And if you look at the map on the right side, you can see in the most of the states, these numbers are increasing. So if we are through the energy transition, we are not going to completely stop drilling for oil and gas. So you can see that this curve is increasing, maybe at, let's say, lower rates, but you're going to increase a lot of wells to this database. And at some point, you have to decide that, okay, either to plug and abandon these wells or use them or recycle them for other applications. So the idea is to look at this database and see the wells that are suitable for this application. So again, the big caveat here is not every well is useful, because you have to be conscious of the well integrity and the well conditions, the formations, to be able to have the enough characteristics for the geothermal production and other things, that we have to consider. So the other thing about this idea is a lot of these wells are close to the population areas. So there is estimate that up to 15 to 20 million people, they are living close to these wells. And the closer you be to the source of the heat, they're going to be less cost. So they're going to be less investment needed for the pipeline. They're going to be easier for many of the workforce that we can use. For instance, converting these assets, you can use the workforce that are existing in Texas, Oklahoma, Pennsylvania, California. They have experience in well construction, drilling, completion and production. And, this is just maybe a well construction 101 for the oil and gas industry to use and repurpose these wells to geothermal. And it doesn't need necessarily to be electricity. It can be for direct heat. We believe that for heating and cooling, there's no reason you burn gas, generate electricity, and then use electricity to heat up the place. It could be just heat directly used for heating and cooling the end user place. So with having this this project initially funded by the U.S. Department of Energy a couple of months ago, and we have been able to create a consortium around this with having in-kind and cash contributions from many industry members. So there are 4 wells that we are going to demonstrate and use for these applications. The wells are located in Oklahoma, in a city called Tuttle. It's 30 miles east of Oklahoma. And they are in very well condition. They are drilled in, 3 of the wells are drilled in less than 20 years. 2002, 3, and 5, and one of them is a little bit older, 1985. They are at a depth of 10,000 to 12,000 feet. We have looked at the different characteristics of these wells, the well integrity conditions, the microseismicity risks in terms of, if you are going to re-inject and produce from these wells, in terms of, what type of seismicity risk we're going to have. So we have looked at different feasibilities, or let's say feasibility studies for different aspects, and we believe that these are ideal candidates for this project. And we are going to have actually to serve the community with this. So this picture on the left shows the location of the wells, wells 1, 2, 3, 4, and there are 3 schools that are within a mile from these wells. So there is elementary school, middle school, and high school. which we can use this energy from these wells for the heating and cooling purposes of the school. So it's a meaningful contribution from oil and gas industry to the community. Just going a little bit faster here. So around 1,700 students currently enrolled in these schools, which potentially can benefit from this project. We have looked at the energy use and the energy bills and the total expenditure that they have, and this project can save hundreds of thousands of dollars in the utility for these schools. And they are very excited to be part of this project. And we are going to have a kickoff event very soon at the school sites to start this. I like also to acknowledge some of our team members, many of our students that have participated in this project, and also in parallel, we are competing in the Department of Energy Geothermal Collegiate competition, which University of Oklahoma brought the first place on a similar project on a different community at Oklahoma. So we are trying to form a very multidisciplinary team of geology, geosciences, geophysics, petroleum engineering, geothermal expertise, because we believe that this needs a teamwork. This is not belonging to oil and gas or other discipline. It's just a interdisciplinary that we can make this project successful. So there is a short video which I can play in YouTube, so you can get more information about this project and the location and the websites. So the last piece I want to talk is, as part of this project, we are also trying to outreach to the community as a stakeholder engagement. A lot of companies, we are talking from oil and gas to utility to a lot of end users, schools, and we think that this needs a team effort from both industry and community and many stakeholders to make this type of project successful. The other initiative we have is to expand this in the native nations, in the tribal communities. There are a lot of these wells currently in the tribal communities that we think could be upcycled for geothermal applications, and currently we are working on that initiative. I'd like to acknowledge our industry partners, the Blue Cedar Energy, for donating the wells to us, U.S. Department of Energy providing funding, also National Renewable Energy Laboratory for being as part of team member, and receiving some in-kind contribution from Baker Hughes. So thanks for listening, and I would be happy to discuss, and this is my email if anybody wants to contact me. Thanks, Susan.
Oh, thank you. That was wonderful. It's so encouraging and inspiring. I just can't wait to see how they look a year from now. It'll be really exciting, and to see actually what the savings are. So Thank you. And I'm delighted to have a special guest, Ellie Mckinnis. She's from CGG. She's taking time from her vacation in Nova Scotia to come to us today and show us a little bit about a new database that de-risks geothermal prospects and also talks about lithium.
Thanks, Susan. I just want to confirm that I'm sharing okay.
Yes.
Perfect, thank you. Hi, everyone. I'm Ellie Mckinnis, the head of geothermal at CGG. Thank you for the invitation today to share a brief overview of CGG's recently released multi-client geothermal and lithium brine products. CGG is a worldwide multidisciplinary geoscience data, technology, and geothermal company, and our experts support the evaluation and de-risking of geothermal projects from exploration to production and monitoring. With more than 150 targeted geothermal projects, we are committed to supporting our clients towards a lower carbon future. So the first project I'd like to introduce you to is the Global Geothermal Resource Assessment. So this is a multi-client project. This product is comprised of an analytics-ready flat file database, an ArcGIS front end, and a full technical report containing geothermal insights and workflows. The project contains a global geothermal power plant data set, over 500,000 geothermal gradient data points, and over 400,000 individual sites. The project also has 20 geothermal resource maps generated following extensive collation, merging, and QC of geothermal gradient data to calculate conductive heat in place. These maps cover a range of depth to different resource temperature and also are aligned with a range of different geothermal extraction technologies. Global seismicity events have been collated and analyzed in combination with the distribution of recent volcanicity to identify areas with potential for additional convective and advective heat transport. The use of seismicity is a new method in this context and offers a potentially valuable approach to geothermal resource exploration. The geothermal resource assessment can be used for geothermal investments, exploration, and development opportunities. Clients can also integrate their proprietary subsurface data sets and insights within the existing data structure. The second multi-client project is a geothermal lithium brine screening study. This screening tool is designed to support our clients in identifying areas of high lithium potential for cogeneration with geothermal. This product is comprised of an analytics-ready flat file database, an ArcGIS front end, and full technical report. This project contains collated, extensively attributed, and repurposed water chemistry database, temperature data, and connected derivatives, production information with flow rates, and hard rock geochemistry. The project contains over 250,000 rows of water chemistry data associated with geothermal fluids. It is evident that these fluids host a wealth of potential for extracting critical elements. And while the focus of this study is lithium, the global fluid chemistry database covers a wide range of potentially valuable elements associated with geothermal fluids. The tool provides the key attributes to permit active screening and initial exploration for both geothermal resources and their potential for in-demand element extraction, as well as reservoir temperature prediction and identification of technical challenges related to brine properties. Thank you for this opportunity to briefly introduce these two products, and I'd be happy to hear from you if you'd like to learn some more. Thank you.
Oh, this is wonderful. Well, this is incredible, and we do have time now for some questions, and we'll just keep going with the questions until we are until people are finished asking questions. So feel free to turn on your microphone and share. Hi, David.
I've been here.
Yes.
I have a question.
Good.
Saeed, the one thing that's lacking in your presentation and quite noticeable to someone who's based on an economic model is that there weren't any economics, and that what's the current cost of electricity or the current cost of heat at the Tuttle schools versus how much is it going to cost to make your project, and what's the comparison of the two. And the other thing is, you said there was $10 million available for your project. I will guarantee that you'll use half that just as for landman purposes, contacting all the interest owners. Oklahoma does not have a single owner kind of a thing. They have bred like rabbits. I'm one of them over the years. And we have so many relatives down the path that you have to contact before you can go ahead and get everyone signed on to get this project done. So 2 questions: where's the economics, which is true for everyone who made a presentation today? And secondly, what are you going to do about the land issues?
David, thanks for the questions. I think you raised a very good point. I will just go over the second questions on the land. I think it's a valid concern, because right now there's not a regulatory, let's say, cookbook for geothermal in the state of Oklahoma. So it doesn't really clear, the heat or electricity belongs to who, if you're using oil and gas assets. So that's something we are currently working on, hopefully through the discussions that we're going to have with the Oklahoma Corporate Commission. Now, luckily for our application, these lands and the wells are all, owned by one person or one entity. And we had some initial discussions, and they are, open for, for having this project. And you're right, that might be not enough, funding for doing all the pieces. But what we are intending to do in the first phase, so let's call it, this initial phase that we are going to go ahead and do it, is it's just a demonstration that, there's enough heat or energy that's going to be harvested for, for these 4 facilities or the 3 schools that we are going to use. So in terms of total BTU or the kilowatts kilowatts of thermal energy, let's say, going to be available for these facilities. So the land thing is a big concern. Regulation is a concern, but we see some progress, in terms of, ground is shifting, people are becoming more open-minded. The first thing on economics, everything we have done is on paper. So I think everybody can, say it is on the paper, but based on, what we have done on the calculations and the total energy that we could get from these wells, that's going to be good enough for more than 30,000 square feet of space. So that will depend on, to be verified by the demonstration. If we don't need any problems while we are doing this, how much production rate we're going to have in terms of, the hot water. So there are a lot of unknowns, but hopefully next year by this time, we're going to have answers for many of these questions.
Good luck. I hope so.
I'll ask a quick question for Ellie. Is that CGG the same French-based geophysical company, and this is a different branch? And could you put up your email somehow in the Susan, I guess, can put up a chat for your email.
Yeah, you can put your, Ellie can put her contact information in the chat. Plus, you'll be getting an email with a recording of this. So I'll include contact information in that email.
So to answer your question, yes, it is CGG, known for our geophysical capabilities. We've also been involved in geothermal for about 20 years now. And as I mentioned, we've done over 150 projects around the world. So it was a very quiet part of the company, I can say. And it's an area that I got involved in a couple of years ago. And, it's really been a mission to expand what we can offer our clients. I think we're all interested in moving to a lower carbon future, and I think geothermal is certainly a part of that. And then obviously with the critical mineral side associated with the brines, we work very closely with our mining and minerals group within the company. And again, as I'm sure you're aware, the level of mineral production that we're going to need to get to our energy transition targets is going to be huge. So thanks for asking the question.
Thank you.
That was great. Any other questions? Well, if there aren't any-
Well, I have one more for all
Okay,
the
good.
speakers. One of the big issues in the West in particular, we have wonderful maps that show us the heat content from one area to another area. And likewise, you only have to plot the bottom hole temperatures of wells. You have the same thing. So we find many places of low heat, 100 to 250 degrees F. But the issue is dealing with the federal government on most of the land. One of the recommendations I made to people that were looking at geothermal opportunities, at least here in Idaho and northern Nevada, was find private land or find state land, and see if you can't find an intersection with the geothermal resource. Because dealing, even if you're talking about mining, dealing that sounds so good, but it's misunderstood by so many people, that you're in a situation where you've got to have an environmental impact statement, where you've got to have CERCLA, you have all these other things that the BLM has not been moving on for the last several years. And consequently, they're tying them all in with cattle grazing, with wildlife resources, with recreation. And the whole thing they're talking about one area has to be redone. Development wells that took 90 days to approve in Wyoming have taken as long as 3 years in the last couple of years. So consequently, I think the big thing is still dealing with the federal government, the Department of Interior, and the Forest Service over some of these lands that have the most potential.
So I'll just jump in there real quick on that. That's one of the best parts about reusing infrastructure that's already existing, is that you've already gone through that whole process. So for the project up in Oklahoma that Dr. Salih is leading, that is one of those where it's kind of already there. You've kind of already done that, especially for wells and locations where projects or geothermal plants are not performing as they once were. That is the opportunity to go in and re-stimulate wells, because you already have that known resource and you already have that all of the permits in place. I mean, you may need to get new permits for the stimulation, but of that already exists. So that's why we push reutilization of existing infrastructure, because that really does reduce that burden of going through the permitting and all of the different environmental impact statements and just the long list that drives out these projects.
That totally makes sense. We've got a couple of questions. Molly Turco had her hand up first. So Molly.
Hey guys, thanks for the great presentations. I have a question for Thomas Smith. I'm not asking you to give away any secrets, but I was really curious about your, I think you called them your calcite filled fractures. Can you speak more to that? Would there be concerned about maybe filling other fractures? I know usually in geothermal we want those conductive fractures, but I can also see how you don't want your fluid to go away from where it's going to come back up.
Right. So good question. So really what it is, I hearken this very much to when I was with Marathon Oil Company in the 1980s, we were doing polymer floods. And so we were trying to divert water flooding fluids to areas of unswept oil in the reservoir, in a very highly fractured heterogeneous reservoir. Now that was done by cross-linking the polymer and doing different things, viscosity, changes and thicker polymers that diverted it in situ. And there was a patent and trademarks called Marcit that Marathon made a lot of money on over the years because it worked, but it was limited to 275 degrees F. So my experience with that, and then I start seeing, okay, there's DOE project funding opportunities for the very same thing in geothermal. They identified that might be a problem. How do we correct these short circuits at a higher temperature? And I had been working with the surface reaction of making calcite. And I said, well, it's thermally, it doesn't care. It's agnostic to temperature because it comes from the ground, and calcite's already in the ground in many rocks. Nature does it. We're just going to do that on steroids. We're going to accelerate that by pumping pure CO2, like a CO2 frac, in with a high calcium rich brine. And in what that does is if you raise the pH, put a buffer in there, ammonium hydroxide or something like that, that contact point will just drop out calcite, in seconds. And so there's a couple more little tweaks in there that are in the patents, but we're anxious to try this. And I think it's going to be, hopefully it's the go-to solution for EGS and open loop systems.
Awesome. That sounds pretty cool. Thank you.
Thank you.
No, thank you. That was a great question. Great answer. Colin Sayers, I think you're next. So Colin, feel free to unmute and ask your question.
Yeah, I have a question concerning the Tuttle geothermal project. So which formation is being targeted? What is its porosity, permeability?
So there are a couple of formations that we are considering. There is a Viola, Houghton, and one or two more that we are looking at. We haven't finalized which one to use, but the average porosity that we have looked at, it's around 15% or higher. Some concerns we have is which formation has a better connectivity for the hot water circulation and geothermal use. So that's something we are trying to look at as a feasibility study in the next few months to see which formation is best suitable for this application. But all of them have a good range of temperature.
That's great. Thank you. That was a good question and good answer. Another question from Avis Ralifada.
Hi guys, my name is Advice.
Oh, okay,
So
sorry.
yeah, on the geothermal, I'm from South Africa. So in South Africa they haven't implemented any geothermal energy, but now I am working with Petra SA, which is on the offshore wells, and now I am being tasked on whether it is profitable, whether it can be for electricity. Obviously, it's offshore, so the interest is on the for electricity production. So, but the wells, the bottom hole temperature is around less than 200 degrees Fahrenheit. So I just want to know, are you also looking at offshore wells, or is it only onshore wells? And what will be the difference on implementing those projects for both onshore or offshore? Thank you.
I'll just jump in real quick. At the OTC, I presented a paper looking at offshore geothermal, and I can send you a copy of that. It is relatively similar, but there are definitely a lot of differences as well that you have to look at in order to make that work. So I will drop my email in the chat, and if you want to just email me, I can send you a copy of that paper.
Well, oh, good. We have another question. Prince Will. Okay, Chuck. Well,
This is
Yeah.
Martin.
Hi, good evening from here. Can you hear me?
yes.
Okay. Hi, good evening. My name is Prince Will. I'm on this call from Nigeria. So this particular topic is very, very much interested. I can remember I actually registered for this webinar seconds after the ad came up on my social media page, because we are very much concerned about it here in Nigeria, where the firm that I founded is being the first geothermal firm in Nigeria. And actually, for my own graduate degree, that's my first master's degree in exploration geophysics, I'm currently majoring in refitting spent oil and gas wells for geothermal energy exploration. This is, of course, after I pioneered one of the first researches at Nigeria's flagship geothermal site. So my question here to all of the whole industry professionals, of which we've had the pleasure of having here, is that in the case, we all know the oil and gas advancements in the US, in Texas, as one of you said. In Nigeria over here, or in countries that are not geothermal blessed, let me put it that way, is there a way of supporting? What will you tell us in a country that is basically living in oblivion with renewable energy? How can we get into this mix? How can we at least join the geothermal run, especially with using spent oil and gas wells? Thank you very much.
It's a good question.
Yeah, I just asked the question. Didn't you get it?
How to get started in Nigeria?
Yes, or in areas that are not, how we'll put it, and that are not either located on the Pacific Ring of Fire or the East African Ridge. I think, given that I've already
that makes sense. So basically, it's not high heat flow, but it's relatively low.
in my career. Hello, can you hear me? Did you get my question?
I think so. Saeed, would you like to answer that? Because Oklahoma is analogous to that.
Thank you very much.
I'm not sure if I got the question right, but if I understood, asking about if you're not in a very high, or let's say top formations, and you want to use geothermal, what could be done? Or if Susan, can you help me with the question?
Let me be clear here, sorry. Given that I'm in the geographical position of which is Nigeria, of course, the largest oil and gas producing country in Nigeria. And basically, since I founded the first geothermal energy firm in Nigeria, which is 3&3 Consort Limited, what advice would you give me, who as an individual has, even in my graduate degree, integrated geothermal refitting oil and gas, spent oil and gas wells for geothermal energy exploration? How do I get into the mix?
Oh, okay, very good question. So, one of the things we are doing at the University of Oklahoma now, we are offering a geoenergy degree, which is exactly for people with the petroleum engineering background. So there are, I would say, between petroleum engineering and being somebody, to be working in the geothermal industry, you have a lot overlap, such as, the reservoir engineering or drilling or production, that you can easily, catch on with the concepts related to geothermal. So one way is absolutely is self-study, changing the industry, working maybe for a geothermal company to, learn and get trained on many of these concepts. That might be, difficult if you don't have many of this company around. I think the second thing is maybe having, these type of certificates, for geoenergy that you can, gain knowledge or, sort of increase your background based on this type of new stuff. Or I would say, self-study, it's just a lot of things we can learn by studying and, books and doing projects. So I'm not sure if there are any other ways, but, these are things came to my mind.
That's interesting. Ellie might have some insight too, since her work is global.
Susan?
Yeah, I was just going to say there's a lot of great international organizations out there. So the International Geothermal Association, the Pivot Project Inner Space that Jamie Beard heads up. I think I come from the oil and gas world, and my time in geothermal has shown me what a close community we are. And we're a relatively small community. So I would really encourage you to reach out to people, to have discussions with how they've managed to make geothermal successful in their countries, because it's clear that we don't need these incredibly high temperatures that is needed in traditional geothermal and the high enthalpy systems. There's new technologies being developed all over the world, which is bringing geothermal so that is feasible at lower temperatures in all kinds of different geology, which as a geologist, that makes me really excited. So expand your network, reach out, and events like these are great for kind of learning what other people are doing and then connecting with them. Good luck.
Thank you, Ellie. And just to build on that, and also what Saeed was saying, is that it takes an interdisciplinary approach. And so mechanical engineers, et cetera, who are working at optimizing heat exchangers are a critical element in this. Ted, you have a question?
Yeah, I've got a question for Thomas Smith. Thomas, in your work to date, have you noticed any correlation or seen any correlation from these brines with high concentrations of critical minerals and either specific rock types or subsurface formations?
Yes, and specific to Utah, it tends to be a brine deposit that's, say, related to a Mississippian kind of a reef. Any kind of a reef type deposit's going to typically have that calcium or magnesium in it, and it's going to be present as a chloride on the anion side. So you guys know rock origins better than me, but obviously the database, and that is a pretty close alignment. So if you're trying to do some geothermal stuff in sedimentary basins, you're not going to tend to have, obviously you're probably not going to be hot, dry rock type reservoirs. So you're not going to need a brine to implant, but the brines in there are going to have a different mix. They're going to have some sulfates, they're going to have some silicates and things like that that aren't present typically in some of these, what am I trying to say? Not sedimentary, but like limestone type depositional environments.
Great,
That's
thank you.
interesting. Yeah, thank you.
Thank you.
David, were you going to say something?
Susan, I have a question. I'm hoping that I really appreciate the speakers and the different nature of each of their talks, even though there's a common theme other than geothermal, which is good. But I'm hoping that you'll capture some of the barriers that they've addressed and that other questioners have addressed, and we'll put those together for the Division of Public EPS. Geez, my mind just escaped me. Which is the place where we will be creating some energy public policy statements for AAPG. And one of the reasons and benefits that we have from belonging to AAPG is that AAPG doesn't lobby, but does bring information to Capitol Hill about issues regarding our careers and regarding opportunities in energy minerals, geothermal clearly being one of them. And we'll have those public policy statements out this year, hopefully by the end of the year, approved by the EC. So the Division of Public Affairs is on this, but now hopefully we can capture some information from the speakers and the questioners that was presented today and put that in the form of our public policy statement on geothermal, its needs. The other one thing we need is from the electric standpoint, we need the public and the PUCs to understand how geothermal is different from some of the other sources. And we need a little more upfront money in terms of our revenue stream than we do in the back end because of so heavy a financial burden on the front end. Anyway, thank you, Susan. I didn't mean to.
No, that's great. I'm really glad you said that. And that gives me a chance to talk about the DPA and the Division of Environmental Geosciences too. And what we're going to do on September 14th is we're going to have I'll send everybody notice of this. We're going to have an AAPG Academy on orphan wells. And so that will be quite interesting. I'm excited about that. I think I saw Bert Vogler in the audience earlier. He's an expert in California on the water issues involved in that. We'll have Dan Arthur, who's an engineer in Oklahoma, who will be speaking, and also we'll have an operator from Ohio. Ohio really does it right, and he'll talk about what is involved. As the presentations show, it's a huge issue, not just abandoned wells, but also the orphan wells. And I think that Saeed Salehi has talked about the issue of orphan wells as well. But keeping in mind what David Hawk said, it's a matter of getting the lease. Could be challenging in those cases. So anyway, do we have any final questions? Well, I want to thank everyone and just remind you that you will be getting an email from me with a link to the presentation. And I would encourage you to watch it, share it, and come back for our next ones. We really feel like it's an important moment, and the more we learn about the opportunities as well as some of the obstacles, the better. And I know I see people in the audience who have been working in this issue. I think Ashley Dowds is one. I'm glad to see her here. And Cesar Vivas is here, and he's in the Energy Consortium, Geothermal Energy Consortium. So those are just a few. And anyway, just want to thank you, and we'll be in touch.
Thanks, Susan.
Thank you, Susan.
Thanks, everyone.
Thanks, everyone.
Bye, everyone.
Bye.